Okay, so Unit 1, we have to remember the sets of real numbers. So we have the natural numbers, which are the most exclusive group. Those are the counting numbers, so 1, 2, 3, 4. So I'm going to go through these first 12 problems here and just label all the natural numbers. So negatives aren't included in natural. 1 is, so 1 is natural. 3 is a decimal, not a counting number. 6 is a natural number. Square root of 19, we don't know what that is. It's not a nice number, so not a natural number. Again, negatives are not for -1. Square root of 49 is actually equal to 7, and 7 is a natural number. 2/3 is a fraction, not natural. 14 over 7 can be reduced. So remember, we have to make sure that we are reducing all of these completely before we label them, before we put them in groups. 2 is a natural number. Pi is not. A negative fraction is not. And 0 is not natural. We start counting at 1, not 0. Alright, then we have whole numbers as our next group. These just include 0 now, so it's 0 and the counting numbers. So all of our natural numbers are also whole, so I'm going to go ahead and put whole for all of the ones we already labeled as natural. And then we also need to add in 0, so 0 is number 12 here, so 0 is also whole. Our next subset of real numbers is integers. These are now positive and negative numbers, so like -2, -1, 0, 1, 2, and so on. So again, all of the ones we've already labeled, all the natural and whole numbers, are also integers. I'm going to label those. And now we need to look for any negative integers. So like number 1, -15 is an integer. Number 6, -1 is an integer. And that's it. Okay, then our next group is the rational numbers. This is where we have our fractions and decimals now added in addition to everything else that we've already labeled. All natural, whole, and integers, all of those are also rational. So I'm going to go ahead and label, again, all the ones I've already labeled, they're also rational. And then we add in any positive or negative fractions or decimals. So number 3, 7.6 is rational. Square root of 19 is still not rational. That's not a fraction or a repeating or terminating decimal. I should be more clear there. 2/3 is a nice fraction. Pi is not rational. And then -1/4 is rational. Okay, and then irrational is essentially anything that's not rational. So that's, remember, numbers like pi and e are both irrational, and square roots that we don't know, meaning that if you do the square root in your calculator, it gives you a long decimal and not a nice number. So square root of 19 is irrational, and pi is irrational. All the other sets are not included in irrational. A number is either rational, which also includes the integers, whole numbers, and natural numbers, or it's irrational, just kind of just off by itself. And then finally, our biggest group is real numbers, and that is everything. All numbers are real, so we can add real to all of the numbers. Everything is real. All right. So number 13 now, we're given a list, a set of numbers, and we need to identify which ones are irrational. So again, remember, irrational are numbers like pi and e, and square roots we don't know. So if we look at our options here, square root of 7, that's a square root we don't know, so that's good. Square root of 25, though, that is a nice number. Square root of 25 is 5, which is a rational number, not irrational, so A cannot be it. B just says pi. Pi is irrational, so maybe it could be B, but there might be something else we need to include. So we'll come back to that. For C, 1/3, that is a rational number, so it can't be C. And letter D, we have square root of 7, which is a square root we don't know, and pi, which is also irrational. So D is the one that includes all of the irrational numbers. B only has the pi, so D would be the correct answer for 13. All right. Again, same idea. We have our set of numbers here. So first you want to go through and simplify anything. Make sure it's all simplified as much as possible. So 0 is good. Square root of 81 is equal to 9, so we treat that like a 9. Negative 11 is good. 7 over 8 is simplified as much as we can. Can't do anything with square root of 3. The only other thing that can be simplified is here, 6 over 2. That's equal to 3, so we treat that like a 3. All right, so whole numbers are 0 and the counting numbers. So that would be 0, obviously. 9 is a counting number. So our square root of 81. And then 15 and 3, so 6 over 2. So we need to look for our answer choice that has all of those. Oh, and 1 is in there too. Oops. So we have letter B is the one that has all of them. 0, square root of 81, 1, 15, and 6 over 2. So B would be your answer. If you want to do some eliminating, A has that negative 11. Negatives are not natural numbers. Letter C does have all whole numbers, but it's missing a few. It's missing the square root of 81, so that's why it can't be C. And same thing with D. D does have all whole numbers, but it's missing square root of 81 and 6 over 2. So you just got to make sure you're including all of the whole numbers. Natural numbers for number 15 are just the counting numbers, so 1, 2, 3, and so on. So it's going to be the same as the whole numbers, just not including 0. So we need square root of 81, 1, 15, and 6 over 2. Oh, and it looks like there's a typo in this one. I remember from last year. So the correct answer should be A with the square root of 81 added in there. All right. And 16, all the real numbers. Remember, real numbers is all numbers. So it's be the set that has everything in it, which is C. C is the one that includes everything. All right. 17, properties. So what they did here is they distributed this 3. They multiplied that 3 inside the parentheses there. So that is using the distributive property. So number D. Number 18. So what happened? The order stayed the same. We still have 286, 286. So that means it's not commutative. Commutative is when the order changes. They didn't do any multiplication. They didn't do any distributing, so it's not the distributive property. Since the parentheses moved, that's what makes it the associative property. And then the numbers that we're dealing with are being added. The parentheses moved around an addition problem. So since we're adding, that makes it the associative property of addition. So B is the correct answer for 18. Okay, number 19. So commutative is where the order changes. So we can go through and eliminate ones that don't have that happening. So 8, the order changes, letter A, the order changes, so it could be A. For C, they kind of just wrote out multiplication as addition, which is cool, but that's not the commutative property. For B, they just did multiplication. That's the closure of multiplication. Order didn't change, so it's not B. And for D, I don't really know what they did there. It's not even a correct statement, so D is wrong. So that automatically means it's A. And that's because it's of multiplication. The numbers are being multiplied. So A is the correct answer for number 19. Okay, number 20. Which of the following properties is being used? So we have the order again is the same, ABC, ABC, so that eliminates commutative. So I'm going to get rid of that. They don't do any multiplication. There's no distributing happening, so we can get rid of that. What changed is that the parentheses moved, which is what makes it the associative property, and the numbers are being multiplied. So that makes it the associative property of multiplication. So C is the correct answer. All right, now moving on, we're doing operations with fractions, and we want to make sure we reduce to the lowest terms if possible. So number 21, we're adding. Whenever you are adding or subtracting, that's when you have to find the common denominator. So if we look at our denominators, we have 3 and 15. A number that both 3 and 15 can go into is 15. So we can multiply our first fraction there by 5 to get a denominator of 15. And then our second fraction already has that denominator, so we don't need to do anything different there. So we'll be left with 5 over 15 plus 4 over 15. Then when we add and subtract fractions, we do the addition or subtraction in the numerator, but the denominator just stays the same. We don't add the denominators. So this would be 9 over 15, which can be reduced. Remember, you can use your calculator to reduce fractions. You would type 9 divided by 15 in your calculator, hit enter, and then do math, enter, enter, and that will reduce the fraction for you, which gives you 3/5 as your final answer. Number 22. Again, we're adding, so we need to find a common denominator. 66 is a number that both 3 and 66 can go into. So 66, our first fraction already has that denominator, so we can just look at our second one. We have to multiply 3 by 22 in order to get 66. So we multiply by 22 in the denominator and numerator. Whatever you do to the top, you must do to the bottom. So we'd have 7 over 66 plus 22 over 66. And again, the addition will happen in the numerator. So that'll give us 29 over 66. And then once you get a fraction, you always want to double check that it's reduced completely. So in your calculator, you do 29 divided by 66, and then math, enter, enter. And it turns out 29 divided by 66 is reduced already. So that would be your final answer. All right, number 23. Okay, so we're adding again, so we need to find a common denominator. Now remember, if you're looking at two denominators and you can't really think of a number that both of them can go into nicely, that's okay. When in doubt, you can always just multiply each one by the other fraction's denominator. So what I mean is with our first fraction here, we can multiply that top and bottom by the second fraction's denominator. So we can take 24, multiply our numerator and denominator. And then for our second fraction, we can take the denominator of 16 and multiply that in the numerator and denominator. It just means you're going to have some bigger numbers to deal with, and you have to definitely reduce at the end, but your calculator does the reducing for you, so it's not that big of a deal. So in our numerator, for our first fraction, we have 11 times 24, which is 264, over 16 times 24, which is 384, plus 13 times 16 is 208, and then 24 times 16 would give us 384. So then we do that addition in the numerator. Gives us 472 divided by 384. So we can go ahead and reduce that. So 472 divided by 384, and then math, enter, enter. And that gives us 59 over 48. And now, if you note, this is an improper fraction. Our numerator is larger than the denominator. But if we look at the directions, it doesn't say that we have to convert improper fractions to mixed numbers. So for right now, we can just leave that as 59 over 48. All right, 24. Subtractions, we need a common denominator. 100 would be a common denominator for 150. So our first fraction is good. If we look at our second fraction, we just have to multiply the numerator and denominator by 2. So we'll have 17 over 100 minus 10 over 100. And again, we just do the subtraction in the numerator. So 17 minus 10 gives us 7, and the denominator stays the same. Always double check to see if you're reduced all the way. So 7 divided by 100, and then math, enter, enter. And it does give us 7 over 100, so that would be our final answer. 25, we need a common denominator because we are subtracting. 55 could be a common denominator, so our first, Again, with all of these too, you don't have to, there's not one right common denominator. You could always just multiply each fraction by the opposite fraction's denominator, and that will give you the right answer. You'll just have to do some extra simplifying, but your calculator will do that for you at the end. So whatever common denominator I'm using, that's not the only option. Okay, so I'm going to use 55 though, so I'm going to multiply my first fraction, numerator and denominator, by 5. So I'll have 15 over 55 minus 10 over 55. Do the subtraction in the numerator. 15 minus 10 is 5. Denominator stays the same. And then let's see if we can reduce that. 5 divided by 55. And then math, enter, enter. Should give you 1 over 11 as your final answer. All right, 26. Oops, over here. 26. Okay, so now we have a mixed number. This 1 and 11/13 is a mixed number. We need to convert that to an improper fraction before we can do any subtraction. So remember, we can use our calculator to do that. We can type in our calculator 1 plus, and then in parentheses, 11 divided by 13. And then we can use our math enter, enter button to get that as a fraction. So again, it's 1 plus, and then in parentheses, 11 divided by 13. Hit enter, gives you a decimal, but then hit math, enter, enter, and it'll put it into a fraction for you. So 24 over 13 minus 3 over 26. So now it is subtraction, so you need a common denominator. So we can multiply we can use a common denominator of 26. So I'll multiply my first fraction by 2. So I'll have 48 over 26 minus 3 over 26. So I subtract the numerators, which will give me 45 over 26. And then we can make sure it's reduced, so 45 divided by 26, and then math, enter, enter in your calculator. And that is the final answer. Again, it is an improper fraction, but the directions don't say you have to convert those back to mixed numbers, so we can just leave it as 45 over 26. All right, 27. Now we're multiplying fractions. So with multiplication, remember, this is the easy, straightforward one. With multiplication of fractions, all you do is multiply straight across in the numerators and the denominators. We do have a negative number here, though. Make sure you only deal with that negative with either the numerator or denominator. Don't do it in both. There's only one negative sign. I'm going to always put it with the numerator. That's just what I do, but if you want to do it with the denominator, that's fine too. So you multiply straight across. 3 times negative 5 give us negative 15. And then 4 times 6 will give us 24. Then let's make sure we are reduced completely. So in your calculator, negative 15 divided by 24, hit enter, and then math, enter, enter. And that will reduce it for us to be negative 5 over 8. Okay, 28, again, is multiplication, but we do have this mixed number, which you have to convert to a fraction, an improper fraction first. So we can type that in our calculator, 1 plus, parentheses, 1 divided by 8, and use our math, enter, enter button. So 1 plus, parentheses, 1 divided by 8. Close the parentheses, hit enter, and then math, enter, enter. That will give us 9 over 8. So we'll have 2 over 5 times 9 over 8. And now with multiplication, we just multiply straight across. So 2 times 9 is 18, and 5 times 8 is 40. And then we double check, see if we can reduce that anymore. Do 18 divided by 40 in your calculator, then math, enter, enter, and it will reduce it down to 9 over 20 for your final answer. Okay, 29. Multiplication again, but with this negative, only deal with it in the numerator or denominator. So I'll treat it as a negative 13 over 15. So when we multiply, it'll be negative 13 times 4, which is negative 52, over 15 times 3, which is 45. Then we need to see if we can reduce that anymore. So negative 52 divided by 45, and then math, enter, enter. And that will remain as negative 52 over 45. And again, it doesn't say we have to convert improper fractions to mixed numbers, so we're good to just leave it like that. Okay, number 30. Now we're dealing with division. So remember with division, this is the keep change, flip, or same change, flip. Whatever you guys remember, flip the guy and multiply. Whatever works for you. So our first fraction stays the same, that's the keep. we change our division sign to multiplication. That's the change. And then we flip our second fraction. So instead of negative 5 over 11, we'll have negative 11 over 5. And again, I'm just going to keep my negative with the numerator. Now it's multiplication, which we like, straightforward. Multiply straight across, negative 11 over 15. Double check, see if that can be reduced. Negative 11 over 15. In your calculator, math, enter, enter. And it turns out that is reduced already, so that would be our final answer. 31. Division again. So same change, flip. 8 over 9 stays the same. Change our division to multiplication. And flip our second fraction. Now we can multiply straight across. So we'll have 80 over 108. And then use your calculator. 80 divided by 108. Enter, and then math, enter, enter. And it will reduce down to 20 over 27. Okay, 32. Division again, and we got to be careful. We have two negative numbers now. I'm going to keep my negatives with the numerators. So keep negative 4 over 5, change, flip. So now when we multiply, we have a negative 4 times a negative 7, which is a positive 28. And then 5 times 6 is 30. And then we need to reduce, so 28 divided by 30 in your calculator, math, enter, enter. We'll reduce that down to 14 over 15. All right, moving on. So again, addition, we need a common denominator. I'm going to use a common denominator of 15. So I'll multiply my second fraction by 3 in the numerator and denominator. So I'll have 13 over 15 plus 18 over 15. Then I can add my numerators. So give me 31 over 15. Denominator stays the same. Now looking at my answer choices, that's not an option, but I do see that there are some mixed numbers here as options. That means we're probably going to have to convert this to a mixed number because it is an improper fraction. Our numerator is larger than our denominator. So remember to do that. In your calculator, you would type in that fraction, 31 divided by 15, hit enter, you'll get a decimal. Whatever number is in front of that decimal point, so in this case it's a 2. 2 is going to be your integer, that's going to be your big number as part of the mixed number. Then you take that integer, that 2, and multiply it by your denominator. So 2 times 15 gives us 30. And you got to look now to see how far away that number is from the numerator of our improper fraction. So 30 is 1 away from 31. So our numerator of our fraction part of the mixed number will be 1, and the denominator will always stay the same, 1 over 15. And that would be letter B. Okay, 34. We need a common denominator because we are subtracting. So I'm going to multiply my first fraction by 3 to get a common denominator of 33. So 6 over 33 minus 1 over 33. Subtract the numerators. Denominator stays the same. 5 over 33. Let's make sure it is reduced all the way. 5 divided by 33. Math, enter, enter. And it is. And D would be our final answer. All right, 35. Division. So keep our first one, change to multiplication, and flip. Then we multiply straight across. So 9 times a negative 4 is a negative 36. And 13 times 3 is 39. And let's see if we can reduce that any more. So you do negative 36 divided by 39 in your calculator, math, enter, enter, and you get negative 12 over 13, which is option A. Okay, simplifying square roots. So with these, remember, always first just try it in your calculator, see if it happens to be a nice number. So to get the square root symbol, you hit the second button and then x squared, and that'll give you that square root symbol. So let's go ahead and try that for 36. You do second x squared and then 121, hit enter, and it turns out it is a nice number. Square root of 121 is 11. So let's try that for 37. Square root, second x squared, and then 48. Hit enter. That gives us an ugly decimal, so it's not going to work out, but now we need to simplify it. So to simplify square roots, we look for perfect squares. So remember, those are 4, 9, 16. Oops. Jeez. Okay. 4, 9, 16, 25, 36, 49, 64, 81, 100, etc. It goes on. And we need to find one of these numbers that can go into the number under the square root nicely. So just start going through. Just try them. So in your calculator, do 48 divided by 4. That one worked out, but there might be a bigger one, which means we'd have to do less simplifying. So I'm going to keep going a little bit just to see if anything else works. So 48 divided by 9, that's a decimal, not going to work. 48 divided by 16, that one works, and that's a bigger number, which means we probably won't have to simplify as much. So let's try that one. So now I can rewrite this as the square root of 16 times 3, because 16 times 3 gives me 48. Then I can split that up as the square root of 16 times the square root of 3. Now in our calculator, we can evaluate the square root of 16. That gives us 4 with no square root. Once you take the square root of a number, the square root goes away. And then square root of 3, if you try that in your calculator, it's going to give you a decimal. We can't evaluate it, and no perfect squares can go into 3 nicely, so that means we're stuck with it. So 4 square root of 3 would be our final answer. Okay, 38 square root of 18, or negative square root of 18. I'm going to just go ahead and write my negative down here in my answer box just so I don't forget about it. Let's try square root of 18 in our calculator. Square root of 18 is a decimal, so it's not going to work out. So now we need to look at our list of perfect squares and see which one of these numbers can go into 18 nicely. So just start trying. 18 divided by 4. Nope, that's a decimal. 18 divided by 9. That one works. Let's start there. So we'll have negative square root of 9 times 2, because 9 times 2 is 18. Then we can split it up as the square root of negative square root of 9 times the square root of 2. Now we look at one square root at a time. So square root of 9 in our calculator is 3, so we'll have negative 3 with no square root. Square root of 2 does not give us a nice number, and no perfect squares can go into it, so we are stuck with square root 2. So our final answer will be negative 3 square root 2. Be careful of that negative. That's going to be one of those trick answers on the test where they'll just have a positive 3 square root 2 and a negative 3 square root 2. So make sure you're always double checking your signs. All right, 39 square root of 50. So just try it in your calculator. Square root of 50, it gives you a decimal. So we need to simplify. We need to find a perfect square that can go into 50. Just start going through the line. Try your division, see which ones give you a nice number. And it turns out 25 is a perfect square that can go into 50, so we can split that up as a square root of 25 times 2. So we can split that up. Square root of 25 times the square root of 2. Square root of 25 is equal to 5. And square root of 2 we can't do anything else with. So 5 square root of 2, or option C, is our final answer. Okay, adding square roots now. It's kind of similar to adding fractions, where you can only add square roots if the number under the square root is the same. So right now we have square root of 18 and a square root of 2. Those are not the same number. So we need to try to simplify everything as much as possible. Now luckily up here we did just simplify this negative square root of 18. That's equal to negative 3 square root 2. Save us a little bit of time. Now they both have a 2 under the square root, so now we can add them. Now when we add square roots, we only add the numbers out in front. So negative 3 plus 3, and the square root of 2 just comes along for the ride. So we have negative 3 plus 3, which is 0 square root 2, and that is multiplication that's happening there. And 0 times anything is just going to be equal to 0. So 0 is your final answer. Okay, number 41, they both already have the same number under the square root. They both have square root of 3. So that means we can add our numbers out in front. 5 plus 2 is 7. Square root of 3 just comes along. Okay. Number 42. So 10 square root of 5, we can't do anything else with square root of 5, so we need to look to our second square root, square root of 20. We can simplify this one more. 4 is a perfect square that can go into 20, so we can rewrite this as the square root of 4 times 5. It should be the square root of 4 times the square root of 5. Square root of 4 is equal to 2. Square root of 5 has to stay. So now we have 10 square root 5 minus 2 square root 5. They both have the same number under the square root, so we can subtract the numbers out in front. 10 minus 2 gives us 8, and square root of 5 just comes along. All right, 43. Now multiplying is a little easier. You just take the numbers out in front of the square roots, multiply those together, and you take the numbers in the square roots and multiply those together. So in here, remember, this is like an implied 1 square root 3. So 1 times 2 gives us 2. And under the square root, we have 3 times 5, which is 15. And we do need to check to see if that can be reduced anymore. So check in your calculator, square root of 15, see if it works. It doesn't, and no perfect squares can go into 15. So we're good. That is our final answer. Number 44. So again, take the numbers outside of the square root. 10 times 1 is 10. And then the numbers in the square root. 6 times 6 is 36. But we need to check, see if we can reduce. If you do square root of 36 in your calculator, you do get 6, a nice number. So this is multiplication. We'd have 10 times 6 to give us 60 as our final answer. Okay, 45. If we look at the square roots, let's try and evaluate them. Square root of 25 is a nice number that does give us 5 with no square root. Square root 7. And we can't evaluate square root 7. No perfect squares can go into square root 7. So 5 square root 7 would be our final answer. All right, 46. Simplifying square root of 49 times square root of 11. So square root of 49, try it in your calculator. You do get a nice number, which is 7. Try to evaluate square root of 11 in your calculator. You get a decimal, so we can't do that. No perfect squares can go into 11, so you're stuck with 7 square root of 11 as our final answer, which would be letter B. Number 47. We need to simplify because right now we don't have the same number under the square root. Square root of 6 is as simplified as we can get, so if we look to our second one, we'll have 4 times the square root because that 4 has to stay out in front the whole time. 4 is a perfect square that can go into 24, so 4 times 6 should be 4 times the square root of 4 times the square root of 6. The square root of 4 is equal to 2, so we'll have 4 times 2 times the square root of 6 to be 8 square root of 6. So we'll have 1 square root of 6 plus 8 square root of 6. We can add the numbers out in front, give us 9. And the square root stays the same. So it'll give us D as our final answer. Okay. 48. Rationalize the denominator is where you take whatever number is in the denominator and you multiply it by the top and the bottom. So times square root of 6 times square root of 6 in the top and bottom. So we'll have 5 square root of 6. And then in your calculator, if you do square root of 6 times square root of 6, it will give you 6. If you are doing this correctly, you should get no more square roots in the denominator. And then always double check, do the numbers outside of the square root, 5 and 6. See if we can simplify that anymore. So just do 5 divided by 6 in your calculator and then math, enter, enter. But it can't be reduced anymore. So 5 square root of 6 over 6 would be our final answer. Okay, for number 49, you multiply by the square root of 3 because that's the square root in the denominator. So we'll have 2. 6 and square root of 6 and square root of 3 are both in square roots, so we'd have square root of 18. We can multiply those together over 3. And then we can reduce that square root of 18, which would give us, we've done that before. Square root of 18 up here is 3 square root 2. So times 3 square root 2 over 2. 2's over 3. 3's cancel. You're left with 2 square root 2. And then for number 50, so we have a couple options here. We could try to reduce the square root first, but we're going to have to probably reduce it at the end anyway, so we might as well just rationalize first and then go from there. So again, the square root in the denominator is square root of 8, so you're going to multiply the bottom and the top by square root 8. You can only multiply square roots or numbers if they're both in a square root. So in our numerator, we'll have our 3, which just stays out in front, and then square root of 16, which is 2 times 8. And then in our denominator, remember you're always going to end up with whatever that number is under the square root in the denominator. And now looking at our square root that we're left with, square root of 16, if we plug that in our calculator, square root of 16 is a nice number. The square root of 16 is equal to 4. So really we have 3 times, again that's multiplication, times 4 over 8, which is 12 over 8, which can be reduced, again in your calculator, 12 divided by 8, and then math, enter, enter. And it will give you 3 over 2 as your final answer. Okay, number 51, still rationalizing the denominator here. So the denominator has the square root of 5, so you're going to multiply by the square root of 5 in the numerator and denominator. So only the numbers in the square root we can multiply, so 10 stays out in front. Square root of 30, all over square root of 5 times square root of 5 is going to be 5 with no square root. Looking at our square root of 30, if you try to do square root of 30 in your calculator, it's not a nice number. And then no perfect squares can go into 30, so that means it is already as simplified as it can get. So then we just take a look at the numbers outside of the square root, the 10 and the 5, and we can simplify that. So that's 10 divided by 5, which is 2. So 2 square root of 30, which means C is our final answer. And those are all the questions for Unit 1.